Hello everyone, welcome to the channel Statistica Hub. So in the previous lecture, we have done variance, standard deviation, right? We have done these two things and we know that, and in that we have the formula for the variance like 1 upon n sigma xi minus mu's whole square. Okay, this is the formula for variance at that time. Okay. Now, the calculations were tricky by using this formula. The standard deviation calculation can quickly become so complicated because first we have to find the mean and then we have to subtract the every value from the mean and take out the square of it, and then we are going to add all these values. Okay, so it's a bit complicated. So to find the standard deviation, you first have to calculate variance, right? We first have to calculate variance and finding x minus mu's whole square for every value of x. This is quite complicated. Okay, now but there is a much simpler formula for variance that produces same results. Okay, you can see it like here. We have the formula for the variance like here, that is sigma x minus mu's whole square divided by n. Okay, that is equals to sigma. Now I can write it like x minus mu divided by n, right? And that is equals to, let's multiply these. This will be x square minus uh, x mu minus x mu plus mu square divided by n, right? Now this is equals to sigma x square minus 2 mu x plus mu square divided by n. Okay, now we know that my mean, that x bar is equals to sigma x divided by n. Okay, this is the means formula. Okay, so if we just take the summation out for all the values, it will be sigma x square divided by n minus 2 mu mu sigma x divided by n plus sigma mu square divided by n, and that is equals to sigma x square divided by n minus sigma x by n. What is sigma x by n? That is also mu. Okay, this is equals to mu. Now this will be minus 2 of mu square. Okay, plus sigma mu square divided by n. Okay, so if we are adding mu square n times, adding mu square n times, then that will be n mu square, right? We are adding mu square n times, then this will be n mu square. So we got n mu square minus n. This is minus 2 of mu square plus mu square. So we got sigma x square divided by n minus 2 mu square plus mu square, right? And that is equals to sigma x square by n minus mu square. Okay, so this is the simplified version of the formula for the variance, that is sigma x square by n minus mu square. Okay, and the previous formula for the variance was sigma x minus mu's whole square divided by n. Okay, now this is quite complicated because we have to subtract the mean from the every set of data. Okay, let's say if my mean is in decimal terms, then it is quite complicated because if we have a large data set at that time, then it's easier to make calculation mistake at that time. Okay, but here we just have to add the values, take out the squares of the values, add these values, and divided by n minus, we only have to take the square of the mean. Okay, we don't have to perform for every rate of setup, we don't have to subtract mean from that at this calculation. Okay, so this is a quicker calculation for variance. Now what is the variance? Variance is the quicker way of calculating the variance is his. This is the formula for the quicker way. Okay, and the formula for the previous way is this one. Okay, we have discussed this. Okay, now as you can see that the standard deviation is a good way of measuring spread. Okay, but the necessary variation calculation sometimes become quicker, tricky. At that time we will use the variance formula that is sigma x square divided by n minus mu square, and by the value that we got, any type of value by using this variance formula, and we'll take a square root of this variance, that is root of variance. By taking the root of this variance, we will get the value of the standard deviation. Okay, like the previous, in the, like we have discussed in the previous lecture, the only the formula for the variance has exchanged here. Okay, that's easy here. Okay, now the advantage of this method is that you don't have to calculate x minus mu square, which means that it's less tricky to deal with and there's a less chance that you will make mistake. Okay, because in this you only have to calculate summation of x square and mu square, right? Okay, so by using this formula, let's try to do some problem. Okay, to do some calculations. Be the coach, we have the scores of the basketball teams. Okay, and like we have done discuss about the basketball team, that they need one player, basketball team, and this basketball team need one player. Okay, and the coach has selected three players, and from these three players he need to choose one player. Okay, and now the question is which one should he choose? That's the problem that we are doing. Now be the coach, here are the scores of three players, the mean for each of them is 10. Okay, now what does it want is, okay, so one second, here we are. Okay, so be the coach, here are the scores of three players, the mean for each of them is 10. Okay, it is given that the mean for each player is 10. Now your job is to play like you are the coach and work out the standard deviation for each player, which player is the most reliable one for the team. Okay, so we have to calculate the standard deviation for each of the player, and the one which has the less deviation, which has the less standard deviation, is the most reliable player in the team. It's very simple. Okay, so we have the mean for each player, that is 10, right? Now let's use this. So, and the variance formula that we are going to use is sigma x square divided by n minus mu square. Okay, so for this one, what are the values that we have? We have x is value, this is my x. Okay, and this is the frequency, that is f, frequency. Okay, so for calculating the variance for the very first player, we have just square these values, that is 7 plus and 7 square. Okay, it is one time, so we are going to multiply its frequency too. Okay, and 2 into 9 square plus 4 into 10 square plus 2 into 11 square plus 1 into 13 square. Okay, we are multiplying the frequency here. Okay, and how many total number of players, what is the sum of frequencies here? That is n is equals to 10. N is equals to 10. Okay, so we got 49 plus, okay, 81 662, this is 400, this 121 into 2, that is 242, right? Okay, if there is any calculation mistake, just sort it out by yourself. Okay, divided by 10. Okay, now this is my this part, sigma x squared divided by n. We have to subtract the mean tens square from it, that is tens square, so minus 100. Okay, so this is the calculation for the variance that we are performing here. Okay, now let's take the sum of all these values. What will be the sum of these values? Okay, let's do it. That is somewhere like 2 9 10 11 14 15 16 17. Okay, so this is okay, let me use the calculator, whatever be the sum of the values here. Okay, so the resultant of all these values would be somewhere like, I think it is 22. Okay, I have seen the result. So you just perform the calculation here, the sum of all these values, and you will get, after calculating this, that is 22. Okay, so we got sigma square, that is equals to 22. Now what is the standard deviation of these values? That is root of 22. And what is the root of 22? That is approximately, I think, root of 22 is somewhere 1.48. Okay, root of 22 is 1.28. It's not 22, I think it's 2.2. 2.2. 2.2. The value that will come here is 2.2. Okay, I'm sorry about this. So we got the standard deviation 1.48 for the first player. Okay, now what will be the standard deviation for the second player? Let's see that. This is x, this is f. Like we have done for the first player, we'll do for the second player. Okay, so what will be the variance for this one? That is 1 into 7 square plus 1 into 8 square plus 2 into 9 square plus 2 into 10 square plus 2 into 11 square plus 1 into 12 plus 1 into 13 squares divided by total number of frequency sigma of f, that is equals to 10 here. Okay, that is 10, and we have to subtract it from the mu square, that is 10 square. Okay, so we got 49 plus 8 is 64, then is 81 into 2, that is 162 plus 200 plus 242 plus 12 square, that is 144. 13 square is 169 divided by 10 minus 100. Okay, now let's take the sum of these. Okay, now I have to use the calculator for it. Okay, let's take the sum, that is 49 plus 64 plus 162 plus 200 plus 242 plus 144 plus 169. Okay, so we got 1030, 1030. 1030 divided by 10 minus 100, and that is equals to 103 minus 100, that is equals to 3. So we got the value for the variance, that is 3. Okay, so my sigma square is 3. So what will be the variance for value for the standard deviation? That is root of 3, which is somewhere like 1.73. Okay, 1.73. Okay, now let's calculate it for the third player. For the third player, when we are calculating the variance, let's perform it like 2 into 3 square plus 6 is square, 2 into 7 is square, 3 into 10 is square, 1 into 11 is square, 1 into 13 is square, and 1 into 30 is square divided by n. N here is I think 11, that is 11 minus 10 square, that is means square. Okay, now let's compute it. So if we are going to compute it, it will be like this is a 9 to the 18 plus 36, 7 7 49 into 2. 49 into 2 is 98 plus 300 plus 121. 13 square is 169. 30 square is 900 divided by 11 minus 100. Okay, now let's take out the sum of this. That is somewhere, okay, 18 plus 36 plus 98 plus 300, 121, 169 plus 900. Okay, so the sum of this is 106, 1642 divided by 11 minus 100. Okay, and when this divided by 11, we got 149 minus 0.27 minus 100, so that is 49.27. Okay, 49.27. So this is the value for this variance it at for the third player. What will be the standard deviation at this time? That is the root of this, that is root of 49.27. So we got the value for the standard deviation is 7.02. Okay, now look at the values of the standard deviation here. For the first player, we got the value of the standard deviation, that is 1.48. For the second player, we got the value of the standard deviation, that is 1.73. For the third player, we got the value of the standard deviation, that is 7.02. Okay, now player 1 and player 2 both have small standard deviation. These have small standard deviation. So the values are clustered around the mean. Okay, but player 3 has a standard deviation of 7.02, meaning scores are typically 7.02 points away from the mean. Okay, so player 1 has the smallest standard deviation from all these three players. So we will choose player 1 from these three players. Okay, and player 3 is the least to choose. Okay, let's do another problem for more clarification. Okay, understanding the problem. So it is saying that the generous CEO of Starbucks Coffee wants to give all his employees a pay raise. Okay, he is not sure whether to give everyone a straight 2000 raise or increase salaries by 10%. Okay, now the first case is what happens to the standard deviation if everyone at Starbucks is given a $2000 pay raise. Okay, so the standard deviation, what will be the case of standard deviation this time? Okay, so the standard deviation is actually root of sigma x square divided by n minus mu square. I can write it like this because it is the root of variance. Okay, now it is saying what happens to the standard deviation if if everyone at Starbucks is given a 2000 pay raise. Okay, so if it is going to raise 2000, okay, for every employee, then the mean will also raise by 2,000. The mean will also rise by 2,000, right? Because we are adding 2,000 to every value. We are adding 2,000 to every value. So the corresponding mean for all these values also be increased by 2,000, right? So what is the result here is the mean is increased by 2000, that is mu plus 2000 whole square. Similarly this one, we have increased the pay from x to x plus 2000. So the formula is sigma x plus 2000 whole square divided by n, right? Now let's just compute it. So we have got sigma x plus 2000 minus mu minus 2000 whole square divided by n, right? Understand this? How you can, we can write it like this because this is also my n by n. See it here. Okay, I can write this like minus n mu plus 2000 whole square divided by n, and this n works for my summation part. Okay, summation part. So if we take this whole part into the summation, this n will clear out. Okay, so we can write it like this. Now you can see that this is equals to plus of 2000 minus of 2000 will cancel out. This is equals to sigma x minus mu whole square divided by n, and this is the formula for the standard deviation. This is the formula for the standard deviation. Okay, so from this we can see that the standard deviation stays exactly the same, exactly the same. So uh, by giving a pay raise of 2000, the standard deviation would remain same. It wouldn't make any effect. Okay, now let's see the second case. What happens to the standard deviation if everyone at Starbucks is given a 10% raise pay instead? 10% pay raise instead. Okay, so let's take out. So if my pay raise is if my pay is x, okay, so if I increase my pay raise by 10%, that means 10% of x, that is equals to 0.1 of x. Okay, 0.1 of x. So if my previous salary is x and I am getting 0.1 x extra salary, that is equals to 1.1 x, right? 1.1 x. So here we are going to have the pay raise of 1.1x minus 1.1 mu's whole square divided by n. Okay, like in the previous case. In the previous case, we the pay raise is increasing by 2000, but in this case it is increasing by 10%. So when it is increasing by 10%, we have the previous pay of x, and when it is increasing by 10%, then it is with point of x, point 1 of x. So the total pay raise here is 1.1x. Okay, so what will be the mu at this time? The mu at this time is 1.1 mu, and the value here is 1.1 x whole square divided by n. Okay, now let's try to compute it. When we are going to compute it, it will be like summation 1.1 x minus 1.1 mu's whole square, sorry, it is mu's whole square divided by n. Okay, just like the previous case, we can take out the summation by because of n, because of n. Okay, so it will be like summation. You are getting this point now. It is like summation a sigma 1.1 x whole square minus n 1.1 mu square divided by n. Okay, now if I can write this into the summation part like 1.1 x is whole square minus 1.1 mu's whole square, right? 1.1 mu's whole square. Okay, so we can write it like summation 1.1's whole square x minus mu's whole square divided by n. Okay, divided by n. So this is equals to 1.1. We can take out the 1.1 from here. 1.1 summation root of summation x minus mu's whole square divided by n. And this is the formula for the standard deviation. So here 1.1 times standard deviation of standard deviation. So it is asked that what happens to the standard deviation if everyone at Starbucks is given a 10% pay raise. So if everyone is given a 10% pay raise, it is the standard deviation will be multiplied by 1.1 times of the original standard deviation. Okay. Okay. So now I have a question in mind, that is, can we have a standard deviation of 0? Can the standard deviation either be 0, every be 0? Yes, it can. The standard deviation is a 0 if all the values, okay, standard deviation can be 0 if all the values are the same. Okay, and what we are meaning to say is that if each value is a distance of 0 away from the mean. Okay, if each value is a distance 0 away from the mean, then we have the standard deviation as 0. And the possible case for this, that if each value is a distance 0 away from the mean, is that if all the values are the same. Okay, then in that case we have the standard deviation that is 0. Okay, now let's see one more example. Okay, let's do one more. Okay, so let me just erase it. Okay, so my next example is for a group of 200 candidates. Okay, for a group of 200 candidates, the mean and standard deviation of scores were found to be like mean is 40 and standard deviation is 15 respectively. Okay, later on it was discovered that the scores were, okay, actual scores were, the mean is 43 and the standard deviation is 35. Okay, and these were misread as mean was misread as 34 and the standard deviation was misread as 53 respectively. Okay, now we have to find the correct mean and standard deviation. Okay, now let's do this. How we can do this? Okay, so we have n that is equals to 200. Okay, we have mean mu that is equals to 40 and we have standard deviation that is equals to 15. Okay, now what is mu? Mu is 1 upon n sigma xi. Okay, that's it. There is a formula for the mean. So from this we can take it out like sigma xi n into mu. And what is my n? N is 40 and the mu is n is 200 and the mu is 40. Okay, so we got summation of x size that is equals to 8,000. Okay, now what is the formula for the variance? The formula for the variance is 1 upon n sigma xi square minus x bar square, minus mu square. Okay, now that is equals to 1 upon n. If I take out the if I want to find the value of the sigma xi square, now that is equals to sigma xi square is equals to n mu square plus sigma square, right? And summation of xi square is equals to n 200. So mu square is 40 square. 40 square, what is 40 square? That is 1600 plus summation plus sigma square, that is 15 square. 15 square is, I think, 225, right? And that is equals to 200, and the sum of these is 1825. That is equals to, let's just multiply this. This is 0 0 10, okay, 365. Okay, so we got the value for summation xi square, that is equals to 365000. Okay, so we have the values of summation xi and summation xi square by this. Okay, now what is corrected sigma xi? Corrected sigma xi. So the previous sigma xi is 8000. Okay, and what are my values? My value is previous sigma xi is the 8000. Mean is misread as 34. Okay, mean is misread as 34, and it is misread as 53. Okay, so we will do it like so the so ow. I'm so sorry, these are not the means. I have just, these are the scores. I have written it down. So these are the scores. These are the scores. Okay, so let's just see it from the very starting. We have 200 candidates, and the mean and the variance for these is this. Okay, and these are the scores 43 and 35. They are being misread as 34 and 53. Okay, I have just given them the symbol of mean and sigma. I'm so sorry about that. Okay, so these scores have been misread like this. Okay, so we have n is equals to 200, mu is equals to 40, and sigma is equals to 15. So we got summation of xi, that is equals to 8000, and we got summation of xi square, that is equals to 365,000. Okay, now we are going to find corrected sigma xi. Okay, so for corrected sigma xi, we are going to subtract the values that are being misread and add the values that are correct. Okay, so this is my total sigma xi. We are going to do minus of 34, minus of 53, and add the corrected values, that is plus of 43, plus of 35. Okay, I'm sorry about the confusion. And that is equals to 8000 minus 30. This is what? This is the sum of, this is 87 minus of 87, and this is, I think, 78. Okay, so we got this minus 9. Okay, so 8000 minus 9 is 7991. Okay, now what is corrected mean? By this we can find the corrected mean, that is equals to corrected sigma xi, that is 7991 divided by total n 200. So we got mean, that is equals to 3 9 5, and there are two zeros. Okay, 39.95 is the corrected mean. Okay, now what is the corrected variance? Corrected standard deviation. Okay, so for that we are going to use corrected sigma xi square. What is corrected sigma xi square? Okay, like we have done for the mean, we are going to subtract the values that are wrong and add the values that are correct. So 365,000 minus 34 square minus 53 square, and add the values that are correct, plus 43 square plus 35 squares, and that is equals to 365,000 minus the square of this is 1156. Okay, I'm using the calculator here. 53 square is 2809 plus 43 square is 1849, and the square of this part is 35 is 1225. Okay, now let's add these values, and we got 364109. This is my corrected sigma xi square. Okay, now from this we will find that what is the value for the corrected sigma square. Okay, what is corrected sigma square? That is sigma corrected sigma xi square. This is 6364109 divided by 200 minus corrected mean, that is 39.995 square. Okay, now what will be the value here? that will be the value here. And when we have to find the standard deviation, we are going to take the square root of this value, and we will get a corresponding standard deviation. Okay, now that's how we can perform the standard deviation example. We can do the standard deviation example. It's easier to calculate by using this formula. Okay, so that's now for all this lecture. In the next lecture, let's meet in the next lecture and let's see what is the next concept. Okay, thank you.